All right, let's turn to the second oligopoly model, and that's the Stackelberg leader-follower model. And that somehow builds on the Cournot duopoly model. The difference is that in the Cournot duopoly model, we assume that there are two players that basically see each other eye to eye. No one is stronger than the other. And essentially what happened in the Cournot duopoly model is that each firm throws a certain quantity onto the market, and then the other one somehow responds with another quantity, and that process iterates up to a point where no changes occur anymore in the responses, and we have an equilibrium. But in the Stackelberg leader-follower model, we do not assume a simultaneous interaction, but a sequential one. And we have a leader, and that leader can anticipate the response function of the follower and already incorporate that into their profit maximizing calculus. So let's derive that step by step. And we will see that we need to steal some information from what we have already calculated in the Cournot duopoly. But let's start by deriving the Stackelberg leader-follower model. So the Stackelberg leader-follower model doesn't inform who is the leader and who the follower, so that's a given. The only thing that the Stackelberg leader-follower model can show is what happens if one is the leader and the other one the follower. So we have to make a decision who the leader will be, and let's say this is firm 1. So firm 1 is the leader, and the follower is firm 2. So now we already know the response function of the follower because we calculated that earlier. So that response function was A minus M over 2B minus 1/2 Q1. That was the response function of firm 2. And we derived that earlier. So as I said, the Stackelberg leader-follower builds on the Cournot duopoly. Essentially what it does, it converts a simultaneous game into a sequential one. Okay, and we also we need to remember that the price is equal to A minus B Q1 minus B Q2. Okay, so now how does the leader maximize profit? So the leader will look at his total revenue function, and that is the price, which is A minus B Q1 minus B. So now this is where we need to incorporate the leader advantage. The leader now knows that Q2 is the response to Q1. So what the leader does is it incorporates the response function as part of the total revenue function. Okay, that is the price now. And then we still have to multiply times Q1, because this is just the price times Q1. Okay, so from now on it's just a bunch of algebra, but this is Stackelberg's major invention. basically turning a Coulomb duopoly into a sequential game by allowing a leader to already anticipate the response function of a follower. So now we can maybe clean up that term a little bit. So the total revenue is, let's just focus on the bracket first. So that's A minus BQ1. So then we have here minus B over 2B. So the B cancels out, and then we get minus A minus M over 2 because the B cancels out. Then we have a minus B times negative 1/2 Q, that makes it positive, plus 1/2 B Q1. Nothing cancels here, times Q1. Okay, so now let's see if we can simplify further. Okay, we have here an entire BQ1, and here we have a half BQ1. And here we have a bunch of A minus M's, and here we have an A. So maybe let's take a look at the common denominator for this term. And then we get 2A minus A minus minus plus M over 2. But 2A minus 1A, that's just A, so let's just write A minus A plus M over 2. Okay, so now we took care of this term. So here we have minus BQ1, and then we add half a BQ1. So that still leaves us with 1/2 B Q1 times Q1. Okay, so now total revenue. So now we can multiply through. So that's A plus M over 2 times Q1 minus 1/2 B Q1 squared. So that's the total revenue function. So now the marginal revenue function is the derivative of the total revenue function with respect to Q1, that we get A plus M over 2 minus, the 2 goes in front, cancels out, so minus B Q1. Okay, so this now needs to be equal to the marginal cost. So marginal revenue equals marginal cost. That's the profit maximizing condition. So MR1 equals M. So now we can write A plus M over 2 minus BQ1 equals M. Okay, so then we can put B Q1 on one side, and then we get A plus M over 2, and then I subtract 1M, but I'll just multiply that times 1, so then I get 2M, and I have a common denominator minus 2M. So then we get A minus M over 2. minus m over 2 and then we divide by b, and that's the optimum q. So that's q star. So q star is, well, let's write it here again. So q1 star is a minus m over 2b. So now how much does firm 2 get? So now we have to plug in this result into here. So this goes here. And then we get q2 star equals, okay, a minus m over 2b minus 1/2 a minus m over 2b. So now we can simplify this one. So we have here 4b in the denominator. Let's just multiply everything to 4b. Let's make sure we have everything. So here we have 2b, 2 times 2b, so we have here 4b. Let's make, we have here 2, 4b2, so we multiply here times 2, and here times 2. Then we get 2a minus m minus 1a minus m. So that leaves us with a minus m. So we have the same numerator, but a different denominator, a minus m. So, okay, so those are the optimum quantities. And we don't need this one anymore. Okay, so now we have to recall, this is what we get in the Stackelberg leader. What were the optimum quantities in the Cournot duopoly? Let's just recall again. Recall Cournot duopoly. So here we said q1 star equaled q2 star, and that we calculated as a minus m over 3b. Let's go back and double check. You see q2 equals q1 a minus m over 3b. So what does that mean? The leader in a Stackelberg leader model gets a higher share of the market than they would get in a Cournot duopoly, but the follower gets less. So that's why there might be an advantage to the leader. And what was the price in the Cournot duopoly? The price was a plus 2m over 3, so we can also just write a plus 2m over 3. So a plus 2m over 3. Yeah. So what is the price now in the Stackelberg leader world? So let's calculate that one. So the price will be A minus B times Q1. And I'll already do that with a common denominator for B. So then I multiply Q1 times 2, and I get 2A minus M's minus A minus M. So now we are left with basically 1A minus M and this B cancels out. So, okay, so let's just get everything over a common denominator. So let's multiply this times 4 over 4. And then we get 4A minus A plus M over 4. Well, that is 3A plus M. So that is 3A plus M. So we can so 3A plus M and then what was it, over 4. So 3A plus M over 4. Okay, is this more than in the duopoly? Well, let's just assume M equals 0. So again, assume marginal cost is 0. So then the price is here 3/4 of A, and here it is only 1/3 of A. So that means that the price in the Cournot duopoly is the price in the Cournot duopoly, if M is 0, so then the price in the Cournot duopoly would be 1/3 of an A, and the price in the Stackelberg leader world is 3/4 of an A. So from there we can already infer, because the demand function is linear, that the overall quantity supplied by the leader and the follower must be less than in the Cournot duopoly. So let's double check. What's the total quantity? So Q total. Well, let's get everything again over 4B. So it's Q1 plus Q2, but here I multiply by 2 to get the denominator for B. So I get 2A minus M plus A minus M. So this gives us the total quantity of 3A minus M over 4B. So that is the quantity of the leader and the follower, and the quantity in a Conoto duopoly, the total quantity, is 2 times A minus M over 3B. So now let's also assume that B is 1, and it's a little bit easier. So if B is 1, then we have 3/4 A minus M. And if B is 1 and A is 0, then we have 2/3 of an A, as opposed to 3/4 of an A. So that means the quantity, so let's double check again, so the quantity total in the Stackelberg leader-follower model is greater than the total quantity in the Cournot duopoly, because 3/4 is obviously more than 2/3. And let's double check again the price. I think I did something wrong here. So the price is here A plus 2M, and here the price is A minus B times A minus M, so 2A minus M over 4B plus A minus M over 4B. So this is, the B cancels out, and then we have here 3 A minus M's over 4B, okay. So then we get here 3/4 A uh, 3AM over 4, right? 3AM over 4 minus 3A minus M over 4. Of course I have to subtract that from 1. So that means that the price, I think I made a mistake earlier, so with respect to the price, but the price is now 4A over 4 minus 3A plus 3M. So that leaves us with 1A, so A fourth, so A, so the price is A plus 3M over 4. Okay, I'm sorry, I made a mistake earlier, so, but now everything seems to be correct. Okay, and then you see if M is 0, then marginal cost is 0, and then we get the price is A fourth, and for the duopoly it is A third. So because the total quantity is higher in the Stackelberg leader-follower model than in the Cournot duopoly, the price must be lower too than in the Cournot duopoly. Okay, so the last thing we can calculate are the profits. So for the profits, we assume again marginal costs are 0, And in a Cournot duopoly, the profits were A squared over 9B. Profit, Cournot duopoly. And of course they were the same for both firms. But now we know that the leader has a quantity of so A minus M over 2B and the followers was A minus M over 4B, and the equilibrium price in the Stackelberg leader follower world we just calculated as A plus 3M over 4. Okay, and now we assume again let M equals 0. So then the profit of the leader is because we don't have really any cost, there may be fixed cost, but we don't know these. So let's assume there are no fixed cost either. So then we have just total revenue minus total cost is 0. So then we have A minus M over 2B times the price A plus 3M over 4. But we said, let's forget about marginal cost. So we get then A squared over 8B. Well, we can already see that the leader now makes a higher profit than what the firm does in a Cournot duopoly, because A squared over 9B, and let's just assume B is 1 for example, but doesn't matter, we divide here by a smaller number, so the profit is greater for the Stackelberg leader. What about the follower? Which is firm 2. So now we have A minus M over 4B times the price A plus 3M over 4, but again we assume for simplicity now that M is 0, so we get A squared over 16B, which is less than what they get. So to sum up, in a Stackelberg leader follower model, the leader gets a higher quantity than a firm in the Cournot duopoly. The follower gets a lower quantity. The overall quantity supplied by the Stackelberg leader and the follower is greater than the total quantity supplied in a Cournot duopoly. And accordingly, the price is also lower in a Stackelberg leader model than in a Cournot duopoly. And the leader makes more profit, the follower makes less. So that somehow summarizes a little bit what happens here. So I have summarized it again here, and I assumed for simplicity that I ignore marginal cost, and then you see the leader's output is A over 2B which we derived here, but we still have here the M. You can plug in a 0. Follower was A over 4B. The price is A over 4. And again, it's A over 4 if we ignore marginal cost. And the leader profit is A squared over 8B. And the follower is A squared over 16B, which is less than under a Cournot monopoly. Under Cournot duopoly, I mean. So, to make a long story short, the Stackelberg leader follower model shows that if you are the leader, you are better off than in a competitive Cournot duopoly. But interestingly, the consumers are probably better off because the prices are lower, and the Stackelberg leader total output is greater than under Cournot duopoly. But the leader makes a greater profit and the follower makes a smaller profit. And yeah, that's it. And so we'll just stop here, and then we'll continue with Bertrand competition.